All right, in this video, we're going to just be introducing algebra, and we're going to kind of cover a bunch in this one video as sort of an introduction. Now, when you're on Khan Academy working on the specific modules in the Intro to Algebra category, obviously the Khan Academy videos are going to be a lot more specific about whatever maybe one thing you need help with. This is just to kind of get us thinking the right way. At the end of this video, there's going to be kind of a longer, harder problem that you have to write your answers to in your Google Docs that I've shared with you. Before you're able to take the test, just so you know. Okay, algebra. We're introducing the idea of a variable, and a variable is simply a number that hasn't necessarily been defined yet. For example, if I told you that I got paid $10 an hour, then if I work X hours, I know that the total amount of pay is going to be 10 times X. Regardless of what X is, I can go ahead and write it as 10 times X because I know I get paid $10 for each one of those hours. Variables allow us to work with numbers even if there's a couple different things it could be, or a lot of different things it could be. And this is something that's really important in math. It allows us to sort of understand things even if we don't have all the parts yet, and work with things even if parts of it can change. So when we write a nut problem out, it's important to just recognize the difference between a constant and a variable. A constant is already defined. 4 means 4. It doesn't mean anything other than 4. It means 4 of something. This is 4. It's a constant. It doesn't change. However, a variable, it could be a bunch of different things. We don't know what it is. Therefore, it's called a variable, and it's typically written as the letter X or the letter Y, or it could be the letter T. Actually, a variable could be anything. 4 plus X is no different than saying 4 plus a star, right? The star is a variable. It could represent some value. Or we could use words. We could say 4 plus tips if you worked in a restaurant, right? The point being that it's not defined. We're not sure. There's many different values that it could be. So 2 plus X, this could be anything, right? Because X is a variable. And in real life, there's a lot of different variables. When you're cooking, or when we're talking about money, or when you're trying to figure out what your grade's going to be, you could have variables. And so this is something that comes up a lot in life. And I would encourage you to think in your own life, or what are some things that are uncertain. Now, we can go ahead and solve expressions if we know what X is. Let's say that I tell you 2 plus X, and you say, oh, I don't know what that is. And I said, well, evaluate this if X were to be 5. Let's just say, hypothetically, X is 5. What is this equal? You'd say, oh, well, if X is 5, then 2 plus X is the same thing as 2 plus 5. Therefore, this would be 7. However, X could be something different. It could have been 8, in which case this would be 10, or it could be negative 5. And, well, what is 2 plus negative 5? Let's see. That means go to the right 2 and then go to the left 5 on the number line, so that would equal negative 3. And here's some expressions. I would encourage you just to kind of play with this. Pause the screen. Put some of these in here. Right? If X is 3, well, what is 3 plus 3? This would be 6. But if X is 10, this would be 13. And if X is negative 5, this would be negative 2. And just see how these expressions can change. And this is a good problem because, it can get more complicated. If X is 3, then this means 4 plus 3 minus 5 plus 3 plus 3. So if X is 3, well, 4 plus 3 is 7. And 7 minus 5 is 2. And 2 plus 3 is 5. And 5 plus 3, that would equal 8. But once again, of course, it would change if you substituted a different value in for X. I also want to point out something about multiplying with variables. In life, we come up with just specific ways to write things to make it easier to communicate. If I said the football team had a record of 8-4, if you didn't know anything about how scores were reported, you would say, well, what does that mean? Which one of those is their wins and which is the losses? But you know that at least in America, we always say the wins first, right? 8 wins, 4 losses. And so you would know this means they have 8 wins. Not because it says it, but because there's a conventional way of doing things that you've grown to rely on. Well, the same thing applies for multiplication. When we see 3x, this means 3 times x. But you can see why we don't do it this way, because this is kind of strange and confusing. But so this is just a convention. Even though it doesn't say multiply, you know that when you see 3x, that means 3 times x, because that's the convention that we use to make it easier, so we don't have to do it like this. Now, when we're multiplying, the idea of x being something that can change still holds up. If we look at this, we say, okay, 4x. Well, that could be anything. But if I say evaluate this when x is 3, then you could say, oh, well, 4 times 3 is 12. Therefore, 4x is 12 when x is 3. When x is 3, negative 2x, that's the opposite of 3 2 times, so that must be negative 6, right? Over here, in general, the way that we're doing these, like x plus 2, we call these expressions. And an expression is just a way of explaining what something is. Your name is the expression we use to describe you. And 5 is an expression to describe how many fingers are on my hand. Now, the number of fingers I have on my hand, I could write this as an expression of 1 plus 1 plus 1 plus 1 plus 1, right? Different expressions can be equal to each other. However, this is not the most intelligent way, or at least it's not the easiest way, to write the number of fingers on my hands. Since you know that means 1 finger and 1 finger and 1 finger and 1 finger and 1 finger, then this is sort of where we learn about numbers. We say, hey, instead of saying 1 plus 1 plus 1 plus 1 plus 1, I say that's just 5. And now I can even extend a little bit further. And you have to apologize, my computer is kind of running a little bit slowly. We can have expressions with numbers other than 1. We could say 3 plus 5. That's an expression, right? That is the same thing as just 8. This is 3 ones, and this is 5 ones, so that's a total of 8 ones. And this is 2 ones and 8 ones, well, that's 10. And then this says, hey, but take away 4 of those, so this equals 6. Well, with algebra, this is no different. When we're adding terms, or in general thinking about terms, we need to make sure that they're referencing the same thing. And a good example is, think about like this problem. If I saw 1 car and 1 bus, and then another car, and then 2 buses, and another car, and then a truck, and then 4 cars and 5 trucks. If I said, how many cars did I see? You wouldn't just add all the numbers up, because these aren't all cars. You would say, well, there's a car, and there's a car, and there's a car, that's 3, and then there's 4 more. So you'd say, hey, that's 7. You knew not to add this, because that's not what the question was asking. You can't combine this. This is something totally different. This is a bus. Well, the same thing applies with algebra. If I said, what is 4 plus 8 plus 2x plus 6, okay? Well, you can easily say, hey, this is 4 ones and 8 ones. So that's a total of 12 ones. And we're being asked to add that to, right, 2 x's and 6 x's. So that's 8 x's total, right? This means x plus 6 x's. So x plus x plus x plus x plus x plus x. And you'd say, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 x's, right? However, these are different things. We can't combine these, can we? This is 12 ones. And this is 8 x's. And x may not be 1. So we can't just say that's 20. Oh, well, 20 what? They're not the same thing. You can't, we can't combine these terms because they're different categories. This is ones and this is x's. We can look at a more complicated problem that actually isn't more complicated. It just has a few more steps. We're going to look through here and we're going to say, okay, there's this big, huge problem. But I can identify the different categories, right? There's 3 x's and minus 2 x's. And those are the only x's in here. So we can combine them, but not with anything else. So I'm going to say, well, if I have 3 x's and I take away 2 of them, how many x's are left in this problem? 1x. And then I go and I say, hey, here's 5 ones, right? There's no term associated to it, so that means it's just 5 ones. And here's 8 ones. So how many ones do I have total? Well, I've got 13 ones. And then I look over here and I say, I've got this like minus 2 y's, and I've got 6 y's. So if I have 6 and minus 2, then that leaves me with 4 y's. And I have now simplified this kind of scary looking problem into something that maybe isn't quite so scary. So here's a couple of problems. I would encourage you to pause the screen for a minute and do these, and then I'll explain them. Okay, so if I have 4x's and 3x's, well, that's just 7x's, right? However, if I have 7x's and 9 1s, those are two different things. I can't combine that because these are x's and these are 1s, and they don't mix. So this is already simplified. Here I've got a deficit of 3x's, negative 3x's, and then I'm going to take away another 8x's, right? So that leaves me with an actual deficit, or a negative 11x's. Now this 4, these aren't x's, are they? We can't mix them with this. These are just 4 1s. Same thing here, like this one. There's 2 and negative 2x. These are two different categories. 2 1s and negative 2x's. So I can't do anything. That's simplified. And lastly here, how many x's do I have? 8 and 3. That's 11 x's, right? And how many y's are there? There's 4. And last but not least, how many 1s are there? Well, there's negative 9 1s, or minus 9. So this is the simplified form of this. All right, so the last big thing we're going to talk about in this video is equations. Equations are simply just setting one expression equal to another one. Equation equal. So if I just said x, what is x? You'd say, I don't know. But if I said, hey, x is equal to, it's the same thing as 2 plus 3, you'd say, well, this is 2 1s and 3 1s. I can simplify that, and now I know x is 5. So, well, 4 1s and 8 1s, yep, those can get combined. So x is 12. This means 4 1s plus 4 1s plus 4 1s, right? So x equals 12. And a little bit of order of operations. I can't combine 9 and 4 because they're different categories. This means 9 1s, and this means 4 3s. However, I can go ahead and figure out what 4 3s is. That's 3 1s and 3 1s and 3 1s and 3 1s, or 12. And this is 9 1s, so I can figure out x is 21. However, life is not always quite so simple. X may not be by itself, but that's okay. We can do a little bit of detective work using some of our hardy properties of addition and multiplication to figure out what x is. So we say, hey, if 7 is the sum of x and 5, then if I take 5 away from that 7, I'll be left with x. And now 7 1s minus 5 1s, well, gosh, that's 2 1s, which is the same thing as x. So here's some problems I would encourage you to do using that same kind of process. 8 is the sum of 3 and x. So if you take the 3 away, you're left with the x. So x would be 5, right? And there's some negative numbers and yada, yada, yada. And ooh, the x moved to this side of the equation. But it doesn't change anything, right? Negative 12 is the sum of x and 4. So if I take 4 away from this, then x is negative 16. So I would encourage you to go through and solve these problems. Now, the same thing applies for multiplication, right? I've got 3x equals 9. Actually, let's move over here. 4x equals 24. Well, 24 is the product of 4 x's. So if I break 24 up into 4 categories, right? Inverse property of division. If I break 24 up into 4 categories, that's how many are going to be in x. And, well, what is 24 divided by 4? That's going to be 6. Is x. Same thing here. 50 is the product of 5 x's. So if I divide 50 into 5 equal parts, that will be what x is equal to, or 10. 3 times x equals negative 6. That means negative 6 divided by 3 is x. So x is negative 2. And the last thing we're going to talk about in this video is sometimes you have to do more than one step. And these are called two-step equations. So let's look at this problem. 2x plus 4 equals 8. 2x plus 4 equals 8. So the first thing I'm going to do is I'm going to look at this and I'm going to say 8 is made up of two things. It's made up of 2x and it's made up of 4. So I am going to use that inverse property of subtraction and say, therefore, 8 minus 4. If I take the 4 away, I'm left with the 2x. Oh, well, 8 and 4, that's easy. That's 4. So 4 equals 2x. And then I say, okay, well, now I know that 4 is the product of 2 x's. So if I divide 4 by 2, then I'll be left with x. And one can simply figure out that 4 divided by 2 is in fact 2. I'll do one more. Let's say 4x minus 3 equals 17, right? So when looking at this, I say, okay, if 4x minus 3 is 17, then that means 4x is the sum of 3 and 17, right? This is that inverse property of subtraction. So I'm going to say that 17 plus 3 must equal 4x. Well, I know what 17 plus 3 is. It's 20. So 20 is 4x. And then I'm going to look at this and I'm going to say, okay, well, then that means that 20 is equal to 4 x's. So let's divide 20 by 4 to figure out what x is. And once again, you can see that 20 divided by 4 is 5. Go ahead and do the rest of these. There's practice on this on Khan Academy. What I need you to do before you can take the Intro to Algebra test is solve this problem. This will take a little bit of time. I would really encourage you to do this after you do the work on Khan Academy and feel a little bit more comfortable with it. But I tell you that Jada gets a total of $290 in a week. I tell you how many hours she worked each day that week and how much she got in tips. A little hint, that's not going to have to do with how many hours she worked, is it? And I want to figure out how much she makes per hour. So you're going to have to create an expression, and you're going to have to say, okay, well, how can I write out the amount of hours versus how much she got paid per hour and the tips to figure out how much money she made? And then I want you to go on and tell me a few other things about the problem. You're going to put your answer in Google Docs and write it all out, and that way I can help you with it. I hope this helps. Go to Khan Academy, get some work done on the Intro to Algebra module, and then get this big problem done. Thank you so much.